NVIDIA GTC. Spencer, we are here in front of Humanoid Robotics. We see a lot of videos on social media by remote-controlled humanoid robotics doing showcases. Why are you so focused on AI humanoid robotics?
Sure, that's a great question. AI robotics is one of those things that you have to keep one eye on the future, but you also have to keep one foot on reality.
Yeah.
And in terms of robotics, we always have this, especially when we look in heavy industrial regions, especially like Europe, Korea. These are areas where every moment is money. And so you can't just bring in AI as it's becoming, into its form, into maturity, and deploy this into these real environments and expect that they're going to be performing real tasks right out the gate. Right now, we're still in the learning phase of AI. We're trying to figure out what is autonomy for humanoid robots. How do we train autonomy? How are we maintaining the ability to create skills and make more complicated skills to do more complicated tasks? And as we do that, in the meantime, there's plenty of opportunities for use cases where the humanoid embodiment could still be useful. And so you'll see it with teleoperation for physical security of perimeter areas, or even people that, if they're remote and I need to go check in on a data center, there's absolutely a use case for having a humanoid be deployed in a data center. And so the engineer that gets woken up at 3 a.m. because there's a critical alert, he doesn't have to get out of bed. He could stay in his house and he could actually still do his job, but it removes the need for him to go back and forth between the data center and have to deal with these types of conditions. I think there's remote teleoperation is a great use case for 2 reasons. One, it allows you to use the robots as we're building it, and allows us to stress the systems, the physical systems, the mechatronics of it. So that way we can learn how to build a good humanoid. With autonomous vehicles, we already knew how to build a car. We've been building it for a couple hundred years, right? We kind of figured these out over the ages. And so for us, it was adding intelligence to a car, but not adding a car to intelligence. For us, we have to add both the robot body and the compute. And so it's going to take us a while. So you'll see it on both sides.
Okay, and in the future, you are expecting more AI at the brownfield and real industrial applications?
Absolutely. I think the first area that you're going to see AI, which we've already started seeing it, is in computer vision. Right?
Yeah.
When you start thinking of smart spaces, robots are not just the moving robots. They're also robots that sit inside of the factory, the ones that are actually the smart factory, the building itself. This is also a robotic system because it sees, it reasons, and it acts. And so the same thing with this, right?
Yeah.
I think the first use case is in computer vision. How are you able to interpret reality, and how are you to make some judgment based on it? So how can I understand the semantics of reality? The next is going to be, how do you start interacting with reality? So the first one is actually autonomous vehicles, smart spaces, computer vision, defect detection, and then the next step is, how do you actually have robotic systems that interact with the environment? How do I start touching the real world? Yeah. And that's really the difficult use case. That's an added layer of complexity.
That's a hard task.
It is, yeah. But we'll get there.
Yeah, and the other topic is about, you are showcasing a lot of simulation here, and all the time you have a gap between real world and simulation.
Yes.
You're closing the gap. How close are we right now?
Sure, that's an interesting question. Sim to real is it's a field of study in many ways, right? It's both a research problem and an engineering problem. So to some extent, we actually solve sim to real when you're working with more conventional technologies and conventional robots, where you've seen things in virtual commissioning. We've already closed that sim to real gap. The reason is because the simulators and the tools that you're using to virtually commission these actions and these tasks, they already have the controller. And so the sim to real gap is actually almost none. When you work with these dynamic systems, you're working on continuous control. It has to be able to adapt. And so sim to real really comes down to, what is the task?
Okay.
I think that we have closed quite a bit of sim to real gaps on things like general mobility, just walking around, because we're understanding how to train these policies and then how to identify the differences between our simulator and reality. But as you start getting more complex things like interactions, we still have to solve for fundamental physics simulations problems before we can really start nailing that sim to real gap. Because if we can't simulate cloth very well, then how do you close the sim to real gap, where if you're not simulating it in a physically accurate way, then there's almost no way that it's going to deploy to real.
Without a concrete model in front of it, you can't close it.
Yes, exactly.
And what is the most important point, or the most issues that you can solve with this type of simulation? Most in robotic, I see the offline programming, but in my opinion, there are so many other pieces where you can use the simulation. As an example, you can compare different type of solution to move a part from A to B.
Exactly.
You can simulate all the different types of
ablation tests. Absolutely.
Exactly. And then you choose the right simulation without wasting all the money for that.
Absolutely. Yes. So if you were watching Jensen's keynote yesterday, as part of the OpenClaw demo, there's this auto research bit from a researcher named Karpathy. I think what he's on to makes a lot of sense. I'm going to spin off a ton of AI agents that are able to start doing some scientific tests, and they keep the ones with progress and they discard the ones that don't. That way you're not wasting compute cycles on things that are dead ends, right? The same thing I think could be happening for robotics, and we need it in 3 areas. The first one is on data. How are we able to both ingest real data and then synthesize, augment, and multiply that data so that way we're able to have a large data set to train up all these robots to do the generalist tasks that we hope that they're able to do. The second is, how are you able to validate the policies that you train? Right? When you're training a policy, there's things like reward hacking, and we're still exploring what are the best ways to train policies. But when you evaluate policies, you also have to be swapping the environment. So if I train my policy, there's an environment, and maybe I want to change an environment, change the object, change the material, change the lighting. These are all things that today an actual engineer has to go and make all these scenarios. If you have agents, you're able to start creating these scenarios programmatically. They're able to start looking at which scenarios have yielded better results for these models because they're looking for edge cases. I think that when you bring in agents into the simulation world, there is an entire new way of doing this robotics research and science.
Really interesting point. I never thought about this, to add an AI agent in front of the simulation to get the best result without an engineering support in front of it. So really promising. And where do you see the robotics in the next 5 years?
So in the next 5 years, I think in the next 1 to 3 years we'll see, and I give it a broad range, 1 to 3 years, because there's going to be more robots in the house, but it's going to be what kind of robot? I believe that you're going to have more intelligent iRobot and the Roborox. There's also going to be some type of mobile manipulator. It may not look exactly like a humanoid at first, but we do have needs for things like passive tidiness. How are we cleaning up the house when I'm going to bed or I leave for the office? You don't have metrics like time constraint, accuracy constraints, robustness constraints. These are all things that I think we'll see in the next 1 or 2 years. As we start getting to the 5-year mark, we'll start having robots that are actually able to do real tasks. And when you enable them with a lot of these agentic systems, like we're truly looking at these agentic systems as means for us to bridge the gap between how humans interact with robots. Specifically, how do you task them? How do you program them? If a normal operator can't program a robot, then we are always going to be limited by needing a PhD in order to get a robot to do something useful. Agents really open this up. Natural language opens this up.
I think this is a real gap because it's so complex to program an industrial robot. So you need months. Also after a PhD.
Exactly.
So it's so complex. Because when you make a mistake, it's not
it's a painful mistake.
Yes, it real bad things could happen. Also.
One of the things that simulation also brought us, and I think you're touching it, is it's so easy to break a mechanical system like a robot, because when you're having an end-to-end policy, there's a little bit of a guess on the first initialization where are the torques that I'm expecting to output going to be within a safe zone. So we could do things like just have torque limits to make it inherently safe. But what what we're evaluating here and seeing is that essentially these systems, we have to touch it. We have to solve for mechatronics, we have to solve for Cinderella, you have to solve for data, you have to solve for validation, you have to solve for training. And so we're kind of having to learn this whole thing end to end. And so the last place that you could take agents is actually on the data infrastructure inside of the data center. If you imagine autonomous vehicles, the way that the best data flywheel is, I have lots of drivers on the road, I capture the data, I bring it into the data center. I say there's 24 hours of data, I only need maybe a couple hours because these have unique characteristics. I'll chunk it, embed it, archive it. But what if you could bring agents in, and now they can start evaluating the data as it comes in and start looking for both positive and negative use cases. If I fail because there was some lighting condition that was separate from the type of lighting that I actually had in my pre-training data set, let's have agents automate the ability to take that data, augment it, and then help you retrain the model. Why does a human have to do that? So we can move agents to every stage of this development cycle and help us automate, and that's actually going to be the key unlocker, because it allows us to do way more experimentation, way more research, all in the same period of time.
And a lot of people are a little bit afraid of AI and robotics. How do you see the impact of all these new technologies?
Sure. I think with every new technology, and we've seen this time and time again, that as they disrupt ecosystems, there's always a learning curve. There's always a period of adaptation for society. But what we've also witnessed is that society is very good at making more work for ourselves. And in fact, we end up looking at all these new enabling technologies. There's definitely going to be some need to retrain. But I believe that it's not necessarily the type of thing where it's replacing a role, but it's actually a new role. And so if you've started working with like these agents, and we're coming back, it's the hot thing this year, but I want to impress upon you the importance of it. Agents also, for my team and myself, we're just learning how to manage them. It's not managing humans anymore. Now you're having to manage teams of agents. And so everyone is going to have teams of helpers, all teams of employees that are not human. They're agents. They're working across all of your systems. They're helping you get more work done. And I don't think that people have to be too afraid. It's going to be an augmenting and assistive technology first and foremost.
Maybe one point why they are so afraid is the time of change becomes faster and faster. And so you have to adapt as fast than never in the past. But I like the keynote from Jensen. So he used a lot of AI, and he never had so much task than right now.
Yeah, they have so much more work. One of Jensen's examples that I like thinking of is radiology. We thought that radiologists would actually be put out of business when you started bringing AI to do interpretations of X-rays. In fact, it resulted in a huge swarm of hiring for radiologists. Why? Because now you can do more work across more patients, and actually now with more doctors, you're able to get more patients seen. Right? So the circumstances by which we're trying to solve for these problems with AI is truly important. I think the other important side is making sure that the technologies have enabling factors. Okay, NLP, having natural language. If I can talk to an AI and I don't need to have a PhD, that is the enabling factor that lets everyone be able to leverage these technologies. In fact, it's also the reason why when we say retasking or reskilling our human workforce, it might actually be simpler than we think, because you don't have to go back to school. You have to learn how to talk to an agent in the context that you now need to do a new job. And so natural language might actually make this much easier. I think that over time, AI is going to make it easier for humans to interact with other AI.
Yes, you're absolutely correct. But I think also to use an AI to program a robot, it must learn the safety issues also, and there is a lot of complicated topics.
Yeah. So I would differentiate the time frame by which we start implementing AI across some of these critical systems. I think functional safety, it's absolutely critical for us to use AI to generate scenarios in order for us to test these policies. But as we start thinking about what does functional safety really mean around humans, in society, these all have to be first principles from humans, because we're the ones that are interacting with them. And so we have to come up with the guidelines by which we're very okay with robots being in or outside of certain environments. And so I think we can't let agents do that necessarily in the beginning. But once we build our preference and we have our, we can prescribe, what exactly would be a good way to have robots interacting with us, we're able to start leveraging AI again to help us make sure that it's well, it's robust, it's inside the system, they're following this. There are things that humans can't do because we're not at every place all the time.
That's always a difficult part of the automation, to have fallout strategies. When an error has happened, what is the next step to do? So, and therefore you can also train by agents much faster than by human.
Yes, yeah, exactly. So it's going to be a fast, this year is going to, agents are going to change the way that we all interact with computers. Agents are going to change the way that we think of services. But more importantly, I think for robotics, agents it's really going to change the landscape of what robotics, the robotics path looks like. Because when ChatGPT came out and the AI infrastructure was made available to roboticists, you saw this 5-year development cycle compress into 2 or 3 years. Well, now we have AI agents that can help us, and they can start solving for the really hard problems. One of the biggest problems going into simulation is you have to recreate reality into a simulator. But not everyone's a 3D artist. And so why spend hours or months or, I've literally spent months on trying to create the right environments when you can have an AI agent do it in minutes. And so there's these things that we can do along the way that's going to make things a lot easier, but it's also going to change our concept of what are important tasks, what are important things to solve for. I think it's all going to be reprioritized this year.
And this is also a point about the token, because when you can do it much faster than by human, then you are open to pay for the service.
Exactly.
Because you spend a lot of time by a human, and so you are open to pay a few cents for AI agent to do this task.
Absolutely. I think the really interesting paradigm shift is that now we have AI that are not only doing useful things, but that they're doing useful things with people that don't have to build full systems themselves. It's not just for the early adopters. Like we finally, we're at that point. That's the clause promise is we're there for natural language integration. And this is absolutely what's going to help us kind of move the needle over the next couple of years. Yeah. I'm very excited. It's having AI agents as part of our team is going to make us much more productive. I mean, I'm sure I'll sleep less. It's not going to make me any less busy, but I'm definitely going to have a lot more. We're going to get a lot more done. I think being able to experiment faster, that's really what everyone's so excited about. How do you get more work done where it's automated and I just need to look for results?
You have more tasks in a short period than before.
Backlog, your backlog is longer than you think, and then your AI comes in and starts helping you. Like, actually, I still have lots of tasks.
It's your task.
Yeah, exactly.
It's like ping pong.
Exactly.
Okay.
So we're all going to be busier, but
thank
in a good
you.
way.
Thank you.
So
it was so inspiring. Yeah. Thank you to be here at your amazing show.
Thank you so much for having me. Enjoy GTC.
Thank you.